Gary McLaren with Hydro Designs, and this will be my one and only 30-second plug for our company. We're a unique consulting firm, whereas this is all that we do. We help utilities implement cross-connection control programs, manage them effectively, and then the end result is reduced cross-connections out there within our communities. We work predominantly in Wisconsin, Michigan, Virginia, Florida, and other states. We've done a number of surveys around in Minnesota in years past, and we look forward to helping utilities around the state. I can't stress enough the one thing that we find out there when we survey buildings and help utilities is we find cross connections out there. We find them in volume because many buildings that have never been surveyed for these cross connections within our plumbing systems are often thought to be out of sight, out of mind, never had a problem. What's the big deal? Right? What's the big deal? The end goal of any cross-connection control program should be reduced cross-connections, elimination of cross-connections, not just paid for, okay? Today we're going to talk about the fundamentals of a program, what you can do to implement one, but also I'm going to get into the details of really what these cross-connections are out there that we find in communities, okay? I can tell you this, from working in other states where they had no programs and it was a huge uphill struggle, we've helped utilities succeed in having effective programs, okay? Nearly 100 in Michigan since the 90s, and over 120 in Wisconsin alone within the last 10 years. Went from no programs to a comprehensive program with a notification process, a survey process, most of all, instructing the water customers when cross connections are found on how to correct them. That's the end result of a good program. Okay? That's my plug. 3 key things we're going to talk about today before Dave talks about the regulatory issues and things like that is just some general terminology that you should become familiar with if you're not already. We're going to talk about some program ingredients, and we're also going to talk, and I've got a good number of slides on high hazard cross connections out there. Okay? A couple of common terms. I won't go through all of these, but you should become familiar with some of these. Potable, non-potable water. You may wonder why I said potable instead of potable. Who says potable? But most of us. I didn't tomato. I say potable because as a consulting firm, we have to make our decisions and our documentation based on plumbing code, other regulatory guidelines, and believe it or not, in the Webster's Dictionary pronunciation, it is potable, rhymes with floatable. Gerald, you're nodding your head. Yep, you knew that. I don't know that, but I say potable. Just need to clarify. How about backflow? Back siphonage, 2 forms of backflow, back siphonage, back pressure. Okay, because we can have backflow by 2 means. Back siphonage or back pressure. We're going to talk about that in detail. Backflow preventer device, backflow preventer assembly, testable type. How many have heard of a testable type backflow preventer? You have a nickname RPZ or an RP. Okay, that's a testable type backflow preventer. Not all backflow preventers are testable. Not all backflow preventers require that annual test, but many do. Not all buildings have a testable type backflow preventer, but all buildings have backflow preventers. Hose connections, water closets, toilet tanks, kitchen air gaps, that's a backflow preventer. Point of use isolation. Where do we consume our water at? Where do we take samples from within our water system? Where do we pull our samples from? Where we drink it, right? From the faucet, over here, over there, not just out at the house, right? So therefore, backflow prevention should be, it's required to be, at the point of use. Okay? We'll talk about that a little bit later. Frequency of survey. Facility survey or inspection. I'm going to probably use both terms. You'll hear surveys or inspections. We mean the same thing. Okay? In general, a site survey should be an inventory of the plumbing, the exposed plumbing, and verifying that backflow preventers, based on plumbing code, are where they should be. That's a site survey. Low and high hazard. Now you've heard this term, high hazards. High hazard cross connections. What about low hazard cross connections? They're out there. Low hazard and high hazard type of cross connections. Coffee makers supplied and connected to the water system. Low hazard, if we had a backflow occur, would anybody get sick and die? Probably not. A boiler system with a chemical additive to it, which most boilers do have, potential is high for contamination to really harm someone. So when we talk about cross connections, we have two categories. Low hazard, high hazard. Guess what there's more of out there? Just by nature of plumbing. You got it. A little bit more about that. But in general, cross connections. Now I only have about 40 minutes, 35 minutes till Dave talks. And I'm going to cover some technical stuff. I don't need to overwhelm you. We're going to go kind of quickly. Cross connections. What does it mean to you? Residential, we know we have cross connections out there. Hose bits, lawn irrigation systems, residential boiler systems. May not seem too important on the radar of cross connection control, but what do we have more of connected to our system out there? Building types. Residential. By far. When we approach a program, design a program, implement one, it really should be with this in priority first, is the non-residential. Why? Because they have a higher risk. The typical connections within a non-residential building are usually of greater degree of hazard. Some examples: process use, complex piping alone with interconnections can be a major problem. Chemical mixers, boiler systems, water softener drains, we'll talk about that one. Cooling towers, oh yeah. How many heard about the cooling tower incident in Bloomington? Nobody? They've heard about it. Bloomington heard about it. Happened twice in over a 2-year period. A contractor servicing a cooling tower. Contamination on the campus. Twice. That contracting firm is no longer in business, though. That's local. No matter how technical I get, we're going to talk about code and things like that in many pictures. What we're dealing with is an inherent problem. It's inherent. All water systems have this problem. All water systems will continue to have this problem. Inherent? Why is that? We've got a water system. You guys pump pressure out to. Gerald, what do you pump at usually?
Roughly 56 to 60.
56 to 60. Scott, how about you? What do you usually pump at?
65.
A little bit higher. Does that pressure ever suddenly drop in an area? Can? Does? Main breaks? You betcha. So in the vicinity, when we have a sudden loss of pressure in a large pipe conveying water, we have that sudden loss and smaller pipes connected to it. Now this is just physics. What inherently will happen? Could be brief, could be sustained. Sudden loss of pressure creates a vacuum. That's not opinion, that's a physical reality that's going to happen. Back siphonage. Any plumbing system, large and small, has that potential. We know we have main breaks. We know we do have to do flushing and other things where we're going to have that sudden change in pressure. This is why I say inherent problem. Regardless of regulatory issues and things like that, we're dealing with a hydraulic issue when that pressure drops. And our drinking water supply is on the other end of it. Oh, and by the way, what else is connected to our plumbing system that we get drinkable water from? When have other pipes connected to boilers, and that end supply is supposed to be this, right? So we have back siphonage. Pretty simple, right? Pretty simple hydraulics. These are chemical mixers that we often find in small to large manufacturing companies, process facilities, where they take a concentrate of chemicals, cleaners, degreasers, and whatnot. You see these in laundromats, schools, where they're mixing water with a concentrate. That should be on the cross-connection survey. How about this? This was on a survey that I was conducting in a school about 3 years ago. Potable water supply. Now this is in the lower level mechanical room at a high school, and it was a direct connection to the pool water flow. Pretty simple. Drinking water supply, pool water. I don't know how many of us want to drink pool water. Probably no one. Although I think we all have at one time or another accidentally. Now what's interesting about this picture, folks, is there is a backflow preventer here. Anybody spot it? Where's that at here? Right there. Right here? Right here, Carol?
Yes.
Okay. That's a vacuum breaker. It's designed and approved to be installed under certain conditions to prevent backflow. The way it's installed in this picture is an incorrect installation. Not only is it incorrect, the way it's installed, it's likely that it's not even working. This backflow preventer is designed to be used intermittently, open, close, and it's a direct connection to the water supply, the pool fill. False sense of security. Maintenance person said, well, we have a backflow preventer right here. Yes, it's a vacuum breaker. It's an approved type. It's the wrong type of backflow preventer for this installation. So when we conduct surveys, many things happen in a facility survey besides just looking for backflow preventers. We're making different assessments as a survey. Here's how it'll happen. Okay, we have these, right? Knock on wood, hopefully less this year than other years, right? So what do we have in that vicinity? Or maybe it's just briefly when that break occurred. We have that sudden loss of pressure. And we have neighbors nearby. So here's potentially what's in the basement of this building. Boiler system, pretty common. The problem gets bigger in a low pressure event. 2 missing backflow preventers. Those large pipes out at the main, sudden loss of pressure. Doesn't take much for that hiccup effect to pull something. Maybe not back out to the main supply, but within the plumbing of the building. This is where it's going to change. Oh yeah, and this is also what they put in boilers. Anyone familiar with chemically treated boiler systems? To maintain the system, they add a chemical to it to prevent corrosion and other things. Oh yeah, so Aunt Barb notices this is real-time backflow prevention, or not backflow prevention. And other people notice. Then this happens. Calls go out. Meanwhile, later in the day, once news gets out, this is the typical reaction when there's no cross-connection control program in place. We had no idea. This topic, as important as the tone I'm putting on it today, usually is not resonating with other people outside this room, decision makers, other people within your utility. It's usually not. We want to prevent anything from happening, right? So let's talk about back pressure. Back siphonage, we can have that. Back pressure. How can we have more pressure out there in our system pushing against your 55 to 60 pounds of pressure? Out there in the system, within a building, or in a complex? Now think about that. How could we have more pressure pushing back against the supply? Elevation change. It's a good one. Pumps. Pressure boosters. There's other ways. How about this? Usually happens about October. Places with green lawns. What do they do with irrigation systems? Blow them out. They blow them out. Usually with about 150 pounds of pressure from a trailer-mounted compressor. Hopefully, they've isolated the irrigation system from the home or the bank or the school before they turn on the pressure side. How about this? What happens when we heat up water? Another hydraulic issue, physics. What happens when we heat up water? It expands. Thermal expansion. Boiler systems. Now in this picture, there's a proper backflow preventer right here and an expansion tank to absorb that thermal expansion. Proper installation. So backflow preventers are required by plumbing code to be installed at these certain points of hazard, boiler systems, irrigation systems. Okay, the plumbing code calls for that. The difference though out there in the real world within plumbing systems, guess what? Guess what's not where it should be? Backflow preventers. Until a survey of a facility or a plumbing system takes place, there is a definite false sense of security until we really start to look at pipes. And this is where we find cross connections. Program, why should we have a program? Well, there's going to be an increase of regulatory enforcement to have a program, to be doing something, a few key items. Okay? Minimize risk and liability. Guess what you don't have in your insurance and policy for a water utility? Guess what it doesn't cover? Cross connections. Not covered. Risk and liability can be greatly reduced. As managers here, you can greatly reduce your risk and liability that you may not even be aware of right now. Of course, protect public health and safety. It's in the news. There's no shortage of them. Beat this one to death, but there's no shortage of cross-connection incidents out there. There's no shortage. It happens locally here. It happens all the time. Dave's going to talk about the MBH aspects of things. I'll keep it pretty simple. Here's an interesting one. Medical facilities. This is a contraption that's found in most, pretty much all surgery rooms where they to evacuate, fluids and other things during medical procedures. This system is utilized and then it's wheeled over. It's basically a wet vacuum. It's wheeled over to a docking port in your maintenance room, and they flush it out with water. Guess whose water they use to flush it out? City water supply, village water supply. Schools. One interesting thing about schools, when we start a utilities program or help them develop a program, we recommend that school buildings and other utility buildings, city-owned buildings, are surveyed first. What we find in schools is that boiler systems are often well-maintained. It's often original equipment or slightly modified over the years. But schools, we find, are typically non-compliant when we look at the entire plumbing system. In almost all janitorial closets, they have chemical mixing systems where they use degreasers and floor cleaners, also in the cafeteria areas. So schools in your community, if you could pick one type of building to survey, it really should be where our kids are at school. Car wash is a big problem. What about those other buildings you have, though? The unknowns. How many have some sort of commercial process or industrial type building in your community? To some degree. When we talk about high hazard cross connections, we're not only talking about the factory, the paper mill, the chemical process facility. We have high hazard cross connections in nearly all types of buildings, from homes to medium-sized commercial buildings to large factories. So when we talk about high hazard cross connections, don't limit it to the big, old scary industrial type building. We find high hazard cross connections throughout all kinds of buildings, pretty much everywhere. Here's an equation to keep things simple: documentation, testing, surveys, site surveys, and a plan. If you have these components as a starting base for your program, you'll be off to a very good start. Some other things you'll need to have. Methods of approved backflow prevention. That's pretty much the plumbing code. You'll want to have a copy of that, at least the relevant sections. So when I say plan, you really should develop a folder, a binder, or some sort of system to collect the resources that you'll need for your program. Most of them are out there available free right now. You just should print them, put them in an area where they're accessible. Schedule inspections. How many have a local cross-connection ordinance in your town for your utility? Like Owatonna, they have a good cross-connection control ordinance. Scott, do you have an ordinance in your town?
No.
That's the starting point. That's the starting point if you're talking about the paperwork end of things before surveys are ever conducted. A local rule or a cross-connection control ordinance needs to be in place. It really should be in place for the effectiveness of compliance for your water customers. A couple more slides here and I'll get to some other pictures. How about this group? I'm pretty sure everyone in this room gets it. But when we leave here, we have to answer to other decision makers or bring this topic to the table. Often, they may not see it as a hydraulic issue that it is. Another program, more staff costs, more impact to our water customers. These are going to be common questions from our other decision makers within our utilities, right? Public education should be big, should be high on your list for your program. As you develop your program, you want some sort of method to get this topic out there to your water customers, right? Public image, pretty important. Here's a slide that utilizes to clarify one thing that's often misconstrued, and that's the guy that tests the backflow preventers, the testable type, and then someone that will survey a building. When that tester is on site, usually he's only looking at one testable type backflow preventer. He performs the test on it, does some paperwork, or maybe he has a couple of those throughout the building. That's the certified tester that conducts those tests, provides the paperwork. A surveyor will survey the entire building, all of the exposed piping, and make an assessment based on plumbing code, whether or not backflow preventers are where they should be throughout that plumbing system. I wanted to clarify the difference between a tester and a surveyor, because often when a building owner or a facility will produce paperwork for their testable type backflow preventer, that could be misconstrued as compliance for the overall protection of that building. Okay, so testers and surveyors, two different acts there. Surveying, guy's going to look at is the backflow preventer installed properly? Are backflow preventers where they should be? And he's also going to provide should be written, detail of what a water customer should do for compliance. Okay? Here's a pop quiz, the only one for this morning. Who can legally do, keyword legally do, cross-connection surveys or inspections in in Minnesota? Who can legally do these? Zeke, what do you think?
Seems like anybody can get it, but with a training background, to recognize.
Zeke's right. It's as simple as this. Red alert. Anyone can do cross-connection surveys in Minnesota. For the testing, you do have to be certified, the testing of a backflow preventer. But to do these site surveys, if you implement a program, you can't hire anyone to do your site surveys or train your own staff, hopefully. Anyone can also do roadside muffler repair too. Anyone can. That's legal in Minnesota too. Okay? So, word of caution, if you outsource for your program or the services, the surveying aspect, be it inspections, make sure you have someone qualified and has experience for looking for cross connections. Not just a plumbing license or some guy off the street that can do it at a low rate. Okay? What we're looking for is critical points within our water system. Okay? So we need a skilled, qualified person to do those surveys. How about this? This was on a survey, I believe it was last spring. Now again, here we have a backflow preventer, and it's even the testable type, okay? But does anyone notice something wrong with it? Right here?
It's on the test port.
See, we got some experts in the room here. Exactly. These are test ports. I said this was a testable assembly. Okay, to test it, it has 2 test ports on it, designed for connecting a pressure differential gauge, a very sensitive gauge, so the certified tester performs the test. So here our surveyor comes along, and what a maintenance guy or somebody did is they threaded on a hose bib directly into the test port. Okay? Again, it's an approved type of backflow preventer. It's the testable type. In fact, they even had a test tag on it. That was fairly recent. But the installation was not compliant. How about this one? One of our other surveyors, Rick Kinney, found this one. This is a thread-on vacuum breaker, like on our home spigots and whatnot. And so Rick's there doing the survey, and the guy walking along with him said, "Oh, I fixed that darn thing. It was leaking all over the place." Red flag for Rick. Now this, again, is a compliant backflow preventer. I should say it was. Okay? From 5 feet away, it looked perfectly fine. And that building person said, he fixed it, it was leaking. Rick said, "Wait a minute, how do you mean, sir?" The guy explained, "Oh, it was leaking, you used the valve, and it would spray all over the place, I fixed it." Further investigation, come to find out the guy put it through his drill press and bored it out. Drilled out the guts of it. And then he threaded it back on. So Rick explained to him that it was actually a safety device to protect from any contamination. The guy had no idea, he thought it was another brass fitting. And Rick provided a vacuum breaker for him, and he gave this to Rick for education purposes. But these are the things you'll find out there. It's backflow preventers in place, but something wrong with those. The installation, they've been modified. Here's another one. Testable type. How about our resident experts? Anyone notice what's wrong with it?
Upside down, sideways.
It's installed upside down and sideways. These backflow preventers have limitations on their installation. It can't be installed upside down, sideways, it won't function properly. Again, the surveyor should catch on these things, should notice these things. But a guy could easily, at a false sense of security, look at this and say, hey, it's a backflow preventer, even as a test ports, it's compliant. So the level of details in the surveys, the inspections, is critical to find these sort of things. As part of your program, you should have a process established. For your written plan, you should have a notification process, notify the water customer, conduct a survey. Okay, what if they need to correct something? How do you notify them? How do you inform them what to correct? You need a process involved in your program. What we do is use standardized language, written, sent out to the water customer on behalf of the utility, instructing them exactly on what to do based on plumbing code. And as part of the local program's design, there's a time frame associated with it. 30 to 60 days is reasonable. If we tell water customers, you have a cross connection, go fix it, thank you. What do you think will happen? It's as good as that sign on the wall, right? We have to have a verification process. Notification and verify. Go back and follow up on these surveys to make sure that things have been corrected. Record keeping is critical. Okay, real quick and then I'll hand it off to Dave. 10 common cross connections that we find in nearly every community that we go to. And that's alternative sources, well interconnections, secondary supplies. Okay? Now think about this. In some of your facilities, they may use river water or other sources, secondary wells, for water use inside the building. A good survey will identify any of these things and potential interconnections. Can we have an interconnection with a private well to your municipal supply? No. Can? Should we?
No.
No, definitely not. But we can, and we know that they're out there. So, as part of the site survey, there's some other benefits involved when someone surveys the plumbing of the building. You'll find those alternative sources and other things. How about fire sprinkler systems? All fire sprinkler systems have to have backflow prevention. Has anyone ever seen the water drained out of a fire sprinkler system? Does it look potable or potable? No. It's like soup. So a good survey will document the appropriate backflow preventer, or like in some old buildings that we surveyed, there's no backflow preventer installed on really old buildings. So that water's just sitting in there, growing and rusting, and every time you have a pressure fluctuation, flush or main break, guess what happens when that hiccups? It pulls that water into the supply. People say, oh, I got rusty water for a couple hours, then it went away. Sound familiar? Here's a secondary benefit to a survey. In some communities that we've surveyed, we always document the line size of whatever we were looking at. 6 inch, 2 inch, 1 inch. That's part of our records. We've helped utilities recoup money on some of their private fire sprinkler systems that they were invoicing or billing for because they had the incorrect line size going into the building on the fire mains. This was they had a record of a 4 inch, and it was actually a 6 inch. Pressure washers, pretty common out there, right? How about this? Food and beverage industry. In this picture alone, there's more than one backflow preventer. Can anyone spot it? Nancy, I saw you point over there. What'd you see? Where at? Good eye, Nancy, right here. That's a vacuum breaker. Oh, Nancy's pointing up where? Right here. Here's another vacuum breaker. Here they are. 4 of them. Air gap on the rinse. And by the way, this is a typical installation in a cafeteria at a school or a restaurant. Typical scenario here. Automatic dishwasher, vacuum breaker. This is actually a vacuum breaker for the garbage disposal jets. Down below, there's 2 jets that squirt water in when they turn the garbage disposal on. food industry. Here's one that we can all relate to, or perhaps. Soda fountain carbonators. Anyone familiar with the problem with soda fountain carbonators connected to our water system? Quick story here. When we go to get our soda, how is it mixed? How do we get soda? Here's how it happens. We mix water with CO2 and then the syrup, and we get Mountain Dew or Pepsi or Coke, right? The only way that CO2 will mix with water is under pressure, about 250 pounds of pressure. And this is the common system of how that happens. This is a soda fountain carbonator. Water comes in, and what do you think that big electrical motor does? Pressure booster. It kicks up the water pressure to about 250 pounds of pressure. Then the CO2 gas is injected, mixed under pressure. That's the only way you get carbonated water. Then it goes out to the gun, at the syrup, we get Coke, Pepsi, Mountain Dew, Dr. Pepper. Right? No problem. Here's the reality of things out there, though. Here's the backflow preventer. That's installed on nearly all of these units. The problem is sometimes they're modified because of this. This is the backflow preventer, the double check valve with the intermittent relief valve. So any back pressure is relieved through that clear tubing right here. Where do you think that clear tubing that's usually discharging back pressure and a little bit of fluid sometimes, where do you think that clear tubing goes to? To a drain, right? Where these are typically installed is underneath the dispensing area, where there's styrofoam cups, lids, straws, or they're out back on a shelf. This unit is not usually mounted stationary on a shelf. It's on a small platform. It's prone to getting bumped around. What we find on our surveys is this clear discharge tube that was once in a drain. Guess where it's at now? Because it got bumped. It's over here in the corner of the cabinet. Now where's all that water going? We got a puddle, right? So what do we do with puddles or leaks? Plug them. Plug them. So it's not the system itself, it's when someone modifies this, and we see this often because that flexible hose gets bumped, creates a puddle. And Mr. Manager, we've seen vice grips on it, pinched over duct tape, the port here, a screw threaded right into it to plug it to fix the leak. So now what we have is a backflow preventer with no relief valve, and eventually it ends up failing. And when CO2 under about 250 pounds of pressure mixed with water goes back up and into the plumbing supply and comes in contact with copper, CO2 is very acidic. When the CO2, that mixture, even when it's just a brief hiccup under 250 pounds of pressure, it travels pretty quick, right? When that comes in contact with the downstream copper plumbing, it leaches off copper very quickly. So that movement of the water, whenever we ingest a slight amount of copper, more than we should, which is very minuscule, we get copper poisoning. And it makes us very sick, food sickness-like symptoms. So guess what we find on our surveys on older buildings, bar and grills, where the equipment is out of sight, out of mind. Often we find that the backflow preventer has been modified or removed. Now who would have thought that? The soda fountain carbonator in a building. So when we talk about a high hazard type connection, it's not always what we think it is. A couple other pictures and I'll wrap these up. Lawn sprinkler systems. If you have lawn sprinkler systems, backflow prevention is required at those locations. May not always be a testable type backflow preventer, but it depends on the installation. It could be the non-testable type. Boiler systems, we talked about that. How about tanker connections? Do you have a policy in place? When you sell off bulk water, do you have a policy? Do you have a minimum air gap or a testable type backflow preventer? Definitely have a policy. Here's a surprising one. Water softener discharges. All water softeners have a discharge. Okay? Where daily it discharges and washes out the media. It's that air gap is what's critical. The air gap at the water softener discharge. You find these are very commonly directly connected to a sewer nearby or a drain. Chemical soap mixers, schools, very common. Definitely a high hazard cross connection out there. Medical facilities, food establishments. Here's your number one cross connection that you're going to deal with out there within your program. By far, it's the number one. It's that hose connection, right? Why is it number one out there? We have a lot of them. Everywhere. Think about hose bits on your average building. Everywhere. Right? All kinds of configurations. How about this? This was on a survey that we did. This had a built-in vacuum breaker type fixture. Somehow the guy installed it upside down. I had to. Oh yeah, here's another one we're recently finding in Wisconsin. Water-powered backup sump pumps. Okay, power goes out, still have water pressure. It'll kick on a sump pump powered by water to evacuate the sump drop. Those are out there. Not all of them are installed with Backflow Preventer. Where to start? Where to start? Get a plan. There's resources out there available. We have, if you want to write down one website where you get a lot of resources, it's this, backflownews.com/afterclassmn for Minnesota.html. At that website, you'll find a ton of stuff you can print, put it in your binder, utilize. The MDH regulations are there, the plumbing code is there, all kinds of stuff. backflownews.com/afterclassmn.html. Minnesota Rural Water also has an excellent list of resources on their website. Okay. At this point, I'm going to turn this over to Dave Rindell from the MDH. And Dave, I'll switch over your slides here.
Hey, one quick question for you.
Sure.
Are you finding most municipalities are paying for this program themselves, or do they?
Okay, so the question was, do most utilities that we encounter absorb the cost of the program? And the answer is yes. It's absorbed into the rates because it's an improvement of the water system. Maintaining a good program will improve the safety of the water system, no doubt. So across Wisconsin and Michigan and other states, we find that utilities build it into their cost of operations. Okay. That's not to say that you could take a different approach, but what we find is most utilities absorb the cost, maintain the program themselves, and then maybe put the onus of surveys on the building owners or other entities.
But the service you're finding, are you going to be paid from the cities or from buildings?
Okay, so the question was, as far as the survey cost, do utilities also pay for that? The answer again is yes, and here's why. To maintain the integrity of the program, looking at all these things, recording things, consistency is key. Okay? And if we rely on the facilities to self-monitor and hire their own guy to find the cross connections, you're going to have a huge variety of what people are actually finding out there. Okay? In a perfect world, all surveyors would survey identical, okay? But they don't. A guy could hire a muffler repair guy or hire a high-end survey company. Okay? If you have that approach, you need to make sure that it's consistent, whoever is conducting the survey. So for our clients, over 250 clients, municipalities, They maintain the cost of the program and the surveys for the consistency. So that's the trade-off for the cost. One other question there?
Yeah, on some of the bigger cities, usually water departments are on the outside. Usually the plumbing on the inside is usually the building department. I mean, is this coming down to the operators, or is it, I'm kind of curious why it's coming, down to our side when it shouldn't be coming down to the building department side.
Dave's going to speak about that in detail, but that's a good question. It's whose responsibility, and I think it varies around the state. So Dave will probably answer that question. Thanks everyone for listening and staying awake.
Thanks, Peter. If I don't get to that, just remind me at the end here.